I spent 2 hours on a live contest, a random live contest that was chosen by other security researchers that I was live auditing with. I was showing them my approach to smart contract auditing. They chose the contest. I dove in 2 hours, I came away with around $2,000 worth of findings. Now, funny enough, I didn't even submit the findings because I just didn't care to. But I went back and I had a look and I tallied it up, and the findings that we got in these 2 hours tallied up to being worth around $2,000. So, of course, I'm going to share with you the 2 1-hour sessions that resulted in $2,000 worth of findings being uncovered. So in these two sessions, you'll see the GTDA method, which I covered in a previous video, being put to use. And you'll see how I'm thinking and the questions that I'm asking to be able to uncover these findings that ultimately ended up being worth $2,000. So before we jump into these two different contest sessions where I was auditing Kelp DAO for both of those sessions, of course, my name is Owen, and over the past 2 years, our team at Guardian Audits has secured dozens and dozens and dozens of DeFi protocols, especially more complex and large DeFi protocols. And doing so, we've uncovered over 1,000 different unique findings and over 100 different critical vulnerabilities that we've personally prevented with smart contract security reviews. And we continue to do so at an alarming rate. And my goal with all these videos, and especially this one, is to distill down all of my experience from the past 2 years plus of auditing smart contracts, finding critical bugs, and give it to you so that you can ultimately become a much better security-minded blockchain developer or a much better security researcher in a fraction of the time, learning from all of the mistakes and the experiences that I've gone through. So with that out of the way, let us get into this 2 hours of a live contest, and you can see how we uncovered findings in a short period of time that were actually worth, a decent amount of money. So does anybody have any contests in mind? I can go ahead and share my screen.
I believe there are two contests right now on Code Arena. One ends tomorrow, and one started basically last evening. Both are pretty short. I think one is 350 lines, the other is 300, I think.
Oh, wow, really?
Yeah.
We might be able to do the whole thing.
There's also one on a new platform that I've never heard before, Cantina XYZ, and that's 800 lines. Yeah, they only
We can
have
try the RSE one on the C4.
Yeah, let's see. Okay, we got Canto, Kelp DAO. Let's check this out. See what this looks like. I do want to do a smaller one just so we're actually able to like get to an interesting spot within something less than 20 hours. So let's see, this one looks like it would be good. Let's have a look at the README. Kelp. Oh, this is by Stater. What is it? Receives funds. All right, I don't really know what this is, but I think we're gonna do this.
Yeah, I actually had an overview of this contest. So it's like we have all those staking tokens, right? Like
Mm-hmm.
R8 and all those. So you deposit those tokens into the Kelp, and then they give you the RS ETH back. And these are the reward tokens or something like that. Like restaking the liquid staking tokens. That's what they are doing.
Classic. Okay. All right, great. So we'll pull that up. Let me just create a kelp.md. This is how I like to just have a scratch pad to write stuff. So first of all, I want to set up some goals. So we'll get to set those once we know a little bit more. Next, just an area for notes, and then findings, and yeah. So what we'll do is we'll just write out some goals for what we want to look into, what we want to understand, and then we can use this to just keep track of stuff. Okay, cool. So I get the 45 minutes started, and I'm going to start off. First, I just want to know what's going on here. So it seems like we're taking the staked tokens and we're staking them themselves. It looks like we've got a ton of actually really small contracts here. The biggest one being just a configuration recipient of funds. Okay, we've got an oracle and some receipt tokens. So they've got some known issues. Okay. Nothing too interesting in the README. So what I'll do is I like to just get a quick overview. I'd just like to glance over what all of the contracts look like. Not even really reading the lines, just looking at what kind of functions there are and almost like what's the geometry of each contract just to get a little bit familiar with what's going on. Okay, so this is the config. There's a bunch of only role stuff. Update strategies. So we've got strategies for assets. Okay, and just configuration stuff. Let's see the deposit pool here. Some view functions. What are the important functions? Okay, this is another view function. Okay, this seems like probably the most important function here. Deposit. I'm assuming there's going to be some sort of withdrawal. Okay, so there's this idea of node delegators. So first I'm going to understand what is meant by node delegator. Okay, we can transfer. So there's deposit and transfer. So those are two things as well. So I want to be able to go through deposit. I want to go through transfer to node delegator. Okay, it seems like these, okay, so this is only for the manager. So really the only user facing function here is basically deposit asset from what I can see. All right, great. So then there's an oracle. So another thing that I think we'll probably see what is when we look at deposit. I want to know what RSETH is.
Hi, Owen. Can you check this out? I have posted the flow chart in general chat. Like, how does everything work?
Oh, that's perfect. Okay. Yeah, that is another thing I would do after is, especially if it's really complex, is actually go into Whimsical and make one of these. So we've already got one.
I also posted a blog kind of talking about what RSETH is. Um, that's kind of their liquid restick token. So we could also look at the blog for that documentation.
Yeah, yeah. Yeah, this is good. Okay, so let's see. I want to see. Okay, so they've got the governance sort of risk management node delegator. So the deposit pool. Where are the users coming in? I think the deposit pool is what we just looked at. I think users will interact with this call deposit asset. Yeah. And somewhere we're using probably the Oracle in here. Oh man, IntelliJ is going to be really slow.
Yeah, so it's like the users will deposit the restaked tokens. Then, on the basis of the exchange rate of RSE, they will receive the RSE accordingly.
I might have to use VS Code for this. I don't know why. Yeah, this is annoying. I'm going to open this in VS Code. All right, yeah, so yeah, like you're saying, when we do this, get the amount to mint, we're going to go to the Oracle. Okay, so it'll be interesting right off the bat. I want to see if there's a way to manipulate the Oracle if it's reading anything on chain. We'll see. That's the first thing. So another goal that I'll add. Where's our goals? It's just the Oracle manipulations. Something I want to look into. So yeah, having a look at this deposit pool gets from the Oracle, so the approved assets. So it looks like when we deposit, it is somehow being attributed to or going to the node delegator. So I guess I'll just look into that really quickly. I want to see where these tokens go. So deposit amount. Okay, we transfer from to this. So we actually get, they should just use safe transfer from. I mean, maybe that's a low, kind of a stylistic. I mean, they are handling it, but whatever. And so, okay, it looks like the tokens are actually held here. I want to see what's the connection between the deposit pool and the node delegator. Or, yeah, approved assets. So I guess the restakers here are the users. Yeah, they put in the approved assets and they get the RS ETH. And then in the deposit pool, it says the approved assets are supposed to go to the node delegator, but let's see. So when we mint, yeah, it seems like this is literally just, yeah, it's just minting. So it seems like what happens is we'll put the assets in here through deposit asset, and then separately they'll be transferred to the node delegator by the manager. So that's where I think this arrow comes in, is we transfer there. So that's something interesting in the Oracle. Looks like we should, yeah, we just have basic functions. So we're definitely going to look deeper in a bit on how exactly they're computing the price. Okay, so a node delegator. I see. So basically, the users put their assets in, and then they go to a delegator, which is just basically a fund manager or a strategy manager. Okay, and yeah, as we would expect, there's a deposit asset into strategy function. Eigen strategies. So, I'm not familiar with eigen strategies. I guess we'll put strategies. Here's another thing to look into. And then here is, this should be a pretty basic ERC20 token. So I guess we'll start off going deeper into this. And then once we have a good understanding of this, then I want to go back to the deposit pool and look deeper there. But let's see. So it's an ERC20, upgradable. So, okay, these are constant, so that's good. We've got to make sure that all of these don't have, okay, so these are all the upgradable versions. We'll have to check this contract, the LRT config role checker. Okay, so right here we've got this. Do we have a storage gap? We don't have a storage gap. So I think right there that might be, I don't know if that's a low or a medium in contests, but right now what's happening is we have an upgradable thing here, and there's this abstract contract that we're inheriting from, and it has a storage slot allocated. Now, technically, if we wanted to in the future add, some other storage, something like this, it could be an issue. And so normally they should use namespaced storage or have a storage gap or something like this. So this will be the first finding that I'll just go ahead and write down. So let's see, just write down the line number. And right now I'm not going to spend too much time making it sound good because I want to move on to more interesting stuff. So I'll just write storage variable used in an abstract contract without a storage gap slash namespace storage. Does everybody understand why this is a finding, or does anybody not understand, I guess?
Would you mind explaining it? It's about the memory points, right?
Yeah, exactly. So when we have upgradable contracts, I think what we'll do is let's have a look at like ERC20 upgradable. And so let's go to Open Zeppelin, the upgradable contracts, and we'll find ERC20 upgradable. So this is a contract that they're inheriting from with their RS ETH, and we'll notice that they're doing their storage in a very specific way. So they've got this struct that is all of the storage for the contract, and they don't just have it like a normal storage variable that's just declared here. In fact, they have a very specific location where in storage, this is stored. So in storage, we have slots. Slots can be defined by these 32-byte things here. Now, when I just write a storage variable at the top of a function, like if I put a variable right here, this will automatically, if it wasn't inheriting from anything like this will automatically go to the first storage slot. Right now, with upgradable contracts, you can see that we're not doing that. We want to give a very specific storage slot. So this is just the hash of this stuff right here. And, they're doing some extra stuff to make it even more unique. But basically, we're storing all of the storage that has to do with this ERC20 contract at a very specific location so that we can avoid storage collisions. And I'll recommend, if you haven't, there's a video on my channel going over all of the different issues and stuff like this with upgrades. So definitely, if you guys want to go deeper into that, but essentially we are putting this stuff in a very specific storage slot so that we don't end up getting any storage collisions when you inherit from this thing and you expect one thing to be at one storage slot and another thing to be at a different storage slot. And then, you can get issues with that. And so what's happening here in this contract is that this is the first thing here. This is basically going, and this is going into that first storage slot. Now the issue is if I, for example, had, let's say I had a situation where I had this public var here, and over here, so we've got this. This is going to storage slot 1, since it's technically the first thing in this hierarchy here, the first thing that's going to get declared and put in storage. And then if we go back here, this is going to go to storage slot 2. Now, this is an upgradable contract. And in some cases, I might deploy another version of this in which there is a second, foo storage variable. We might add some functionality to this config role checker contract, and we might need another storage variable. So in this case, this is now storage slot 1, and this is now storage slot 2. But remember, previously we had this, which was previously at storage slot 2. So all of the previous values for this, whatever the value was, that's sitting at storage slot 2 already. And then when we upgrade, that value is errantly assigned to what this will be. And so the way that this was first recommended to be fixed is to add like a uint array of let's say 40 different uints. So this would reserve basically 40 storage slots, and they're just reserved. They're left empty because obviously we don't add anything to this gap array. But that means that when this is a uint 40 like this, instead of this going to 2, this will go to 42. And so what we have is we have all this empty space in these 40 storage slots, where now if we go ahead and we can add, however much stuff we want to here, and it's not going to be an issue, right? So yeah, that's the first. I would if this was one of our audits, I would put this as a low, because I don't think, especially because at present there isn't any storage variables in this rs-eth contract as it is. These are in the actual code of the contract, since they're constant. So I would have it as a low, but it's definitely a finding. But yeah, I guess does that make sense?
Yeah, perfect.
Okay, awesome. All right, great. So yeah, that's just a minor note now. So all of these are upgradable. The initialize one, yeah, this is also from contracts upgradable. So that one should also be using namespace storage, so that's all fine. Okay, let's see. We are correctly using ERC20 init there. Okay, we've got some zero just checks. Okay, let's see. So let's make sure we're initializing everything here. ERC20 upgradable, we got that one. Pausable, we are initting that. Access control, we are initting that. So that all looks good, and we're using this as the initializer. And it looks like we are deploying LRT config. So what is this? This is this contract. So this rs-eth is able to point to the config contract. Let's see why. Okay, you can update it. Why does it matter? Why do we care what this is? I think this will probably matter because of this. Oh, it's for the roles, right? So the config holds the roles. This makes sense. Okay, fair enough. Okay, and then we just want to make sure, of course, there's access control on all of these functions. Looks like we are good. This one, okay, only the manager. Let's see, where does the manager come from? Okay, and this one just checks has role. Okay, so this pretty simple token contract. We might come back to it, but that's just a first pass. The most interesting thing here is the deposit pool for sure. So I'm going to dig into this more. And I'm going to start with deposit asset, and I'm basically going to walk through this flowchart essentially. So let me find this. So we are a restaker. I'm going to walk through depositing into a pool, and then from there we can go into transferring to a node delegator and then getting into strategies. So let's see what that flow looks like. Okay, so we're defining an asset. So first thing I'll note is that this is an arbitrary address. So that's like and I'm gonna put a @audit tag here. What I like to do is I'll like grep for @audit later at the end of the audit. It looks like they've already done this. So I might change this to be @note. Okay. So yeah, I want to note that this is an arbitrary address here. So it looks like they do have control of where like if it's going to be whitelisted, but anytime I see an address being passed in, that's always, we need to think about, is it a contract? Is it not a contract? Can it accept Ether? Can it gas grief? Can it DOS? Can it re-enter? Everything like this. So let's see, we're not allowing zero deposits. We're not allowing, this is interesting, get asset current limit. So is that supposed to be an aggregate or a single? So let's find this definition. Okay, so they are doing this correctly. Get total asset deposit. Right, so in the LRT config, it looks like they're going to be configuring a total cap on how much can be deposited, and then they're basically getting how much room is left between that. So let's see, what's this? This is interesting because it doesn't just rely on balance of, so that's interesting. Okay, because it looks like assets are, yeah, so there's some assets that are going to be deployed into the strategy, basically earning yield in NDCs. I'm not sure, that might be the delegators, something like that. And then that should just be like balance of, yeah. Okay, so right here we have, this is balance of, so they're getting how much does this contract have, how much do the node delegators have, and then how much are in the strategies. And they're doing this, which doesn't, I don't think you need to do that anymore. I don't remember if that's 0.21 or 0.22, in which this is no longer something you should do. It's no longer a gas optimization, since now I think the compiler will do this by default, or the optimizer will do this by the default for you. So I'll just leave that as like a brief note. I want to make sure I've got the right solidity version, but I'll just write down LRT deposit pool 85 unnecessary unchecked optimization, which solidity version. Okay, great. So balance of, I also just want to note, I don't know if this is going to be something we can exploit, but it can be manipulated without calling the deposit function, right? We can just send the asset directly to this contract and change this without having to call the deposit function, which may or may not yield us something, but it's something at the very least interesting. So, all right, let's go back to where we were. So I think this validation for get asset current limit, I think this works. I think this is fine. It's basically saying that I can't put anything in more. Yeah, we'll come back to that. Okay, and then we're actually transferring from the message sender to this. And it's good that they're doing this first thing in the transaction. So whenever we're transferring tokens from, I always recommend that it's done before any updates. So if you're following checkFX interactions like really stringently, you would say that you should put this at the end of the function. But since we're transferring from and we're collecting tokens up front, it's better to do the transfer from before we do any interactions, because really what we want to do is we want to prevent the system from getting into any invalid state at the time when we are making external calls. So this is basically the same as if there were to be two separate transactions, and in the first transaction you just transferred from, and then you called deposit asset. So this is totally fine to do the transfer from first thing, and in fact we want to do it first thing because we expect to have their tokens before we mint. So it's not always the case that you should make external calls last in a function. When we're transferring from, it's usually the right thing to transfer them first. So I think this is good. One thing I'll say, of course, is it's probably out of scope, but I'll just write it here for completeness, is of course it's 136. The note about fee on transfer and rebase tokens. They are incompatible because, of course, it looks like they're expecting to get exactly deposit amount, which might not be true with those tokens. Let's see what else about this. Even callback tokens should be fine, right? Because we haven't done anything yet, and we've got so that even callback tokens should be fine. Blacklist, if the message sender is blacklisted for this, then that's fine. It's just going to revert on them. So I think that's good. We're going to move on from there. All right, let's see, mint. All right, we're getting the amount to mint. This is where we're going, and we're going to talk to the Oracle and figure out, okay, given this amount, we're going to see how much we should actually mint. Okay, we're getting the configured token, and we're minting that. Okay, so really the interesting thing is here is in the pricing. How much should we mint? Okay, so we're getting the Oracle. So it seems like the config is it's also like a registry of where all these contracts are, right? And then we're setting it, configuring where these contracts are. So here's the Oracle. Okay, we're saying the amount. So this is in the asset times the asset price. So I always, when we come to formulas, I always like to whiteboard them out and look at the units specifically for pricing stuff. So let's see what do we have? We've got an amount. So we've got amount of, let's call it asset times asset price, which is going to be dollars per asset divided by the RS ETH price divided by RS ETH, which is going to be dollars per RS ETH. Interesting. So let's see. So this is dollars divided by, so this is going to end up as RS ETH. So this simplifies to dollars divided by RS ETH, which of course becomes the inverse of that. So if we do dollars times RS ETH over dollars, that's what it becomes. And we go boom, boom, and we end up with RS ETH. So the units make sense. Get asset price. I'm assuming this is just going to talk to chain length. So let's have a look at the Oracle now. A price fetcher. So we're getting the Oracle get asset price. So that's not at least immediately chain link. So let's see. Get asset price feed. Oops. So let's see. We've got these oracles. Where are these set? Do they have a price fetcher contract? Chain link price oracle. So this is a price fetcher. Okay. So we've got to just be sure. Okay. Well, right here they need to be using latest round data with a heartbeat check. So that's something right there. So let's see. What is this file called? Chain link price oracle. Okay. So let's write this down. Then we'll talk about what this finding is. In the get asset price function, we need a heartbeat check with the latest round data function. Okay, so does everybody know what this finding is, or does anybody not fully understand what this finding has to do with?
I think it's like something to do with keeping the data fresh, but I still don't fully understand like how the heartbeat check entails.
Okay, great. Yeah, so let's just quickly go to, the Chainlink documentation. So if we scroll down, we'll see a section on checking the timestamp. So what a Chainlink aggregator contract is it's just a smart contract where every so often, depending on the price feed, let's say every like 15 minutes or 30 minutes or something, it depends on which price feed it is. But every 30 minutes, a Chainlink keeper will send prices, they'll submit prices to this contract, and they'll have a bunch of signatures and stuff with it that says like, yeah, this is a valid from the Chainlink network, this is a valid agreed upon price, and they will basically write it to this contract that has, in storage, what is the latest price, what is the latest round data, stuff like this. So they've got a let's see if we can find let's just find a price feed contract. Okay, let's go to ETH USD. Where's the address? Okay, so we can read it and we can see there's this round data function. Get latest round data is the one that we want, and we can query it. Okay, so we can see, so this is like every 30 minutes, this is the data that's getting written, or every however many minutes, right? So we can see with all these, it's got like a started at, updated at, timestamp, round ID. The answer here is the actual price to a certain number of decimals. I think it's 8 for this price feed. So we need to basically, I mean, you can fully trust Chainlink and just like say like, yeah, whatever your latest answer is, I'm just gonna take that. But what if this didn't happen for 90 minutes? Or what if it just wasn't happening at all? And it's like, it's been a day since it's been updated or something, right? So that's why we need to check the updated at against the heartbeat. So the heartbeat is configured per feed, and it is basically saying this feed should be updated every 30 minutes or something like this. So some heartbeats are configured to last several hours. So your application should check the timestamp and verify that the latest answer is recent enough for your application. All right, so if it didn't, for whatever reason, if it wasn't getting updated within the heartbeat, then that's an issue, right? The price that you're reading from Chainlink could be potentially outdated, and then people would just come and arbitrage your system. So that is, I guess, does that make sense?
Yeah, that's good. Amazing.
Cool, cool. And then I think this is going on mainnet, but also there's all, of course, the note about the sequencer uptime check, which is another section that they have somewhere. Yeah, it's somewhere. Yeah, right here. L2 sequencer uptime check. And basically for Arbitrum, for Optimism, Base, and Metis, any of these networks that have a sequencer, basically for, at this point, just Ethereum L2s, you need to also have a check that the sequencer, so the sequencer is another point of failure, is what if the sequencer is not up and it's not actually having transactions go through, and, you know, for whatever reason with all of Chainlink's infrastructure, when that is not up, that's going to basically cause another way that prices can be outdated, right? Without getting into the Chainlink infrastructure too much. But they have another price feed that basically tells you, well, it's not a price feed. They have another feed that just tells you whether the sequencer is up or not. So that is just another thing that needs to be checked. And they go over how exactly that can be done here. It's basically, it just looks like, so this is this is the sequencer up. So they've got a sequencer uptime feed, and then there's a way to check, is sequencer up? If it's not up, then you revert. And then there's another grace period that says, okay, the sequencer has to have been up for at least X amount of time. And then this, and they also, technically here, they should also be checking the timestamp against the heartbeat. But yeah, so that's all the Chainlink stuff. So there's that finding. So let's go back to where that was used. Okay, so we're just getting that price, and basically this is just a trusted price from Chainlink. So we're just calling this, if we go here, yeah, we're just calling it get asset price on that. The more interesting price that we're going to look at is the RS ETH price. So I'm excited for this one. All right. Oh yeah, this one might be manipulatable. So let's see. Okay, so actually I'm going to make this a little bit bigger. I realize that that's been pretty small. Okay, so we're getting RS ETH. We want to get the total supply. So they're hard coding it to $1 if it's, so the base price will be $1. I'm almost interested in some kind of front running attack, but okay, so it's $1 by default. Then let's see. So they've got total ETH in the pool. Oh, it's this is interesting. Total ETH in the pool. This almost doesn't seem to be returning a dollar price, which would mean that these units aren't going to work out. If this is Ether per RS ETH, then this is not going to work out unless they're using a Ether price feed. So they could have Ether per asset. I think those are also supported feeds. They've got ETH denominated feeds somewhere. They've got them. Yeah, so we'll see if that's the case. All right, so we're getting the deposit pool. We're getting all the supported assets. So one thing, obviously, we're looking at this, we're thinking about gas. Yeah, if there's a lot of assets, so we're just looping through all the assets right now. So obviously, if there's 100 different assets, this might become too gas intensive. But obviously, if there's only like 3 or 4 supported assets, then that's not going to be an issue. And it looks like what we're doing in this loop isn't super gas intensive. We're just reading from, okay, so that is in memory. We're getting the asset price. So we are making like a few external calls to Chainlink, and then we're summing the total asset deposits. This could actually be somewhat, because if I'm looking at this, we go to the deposit pool. Let me just copy that function name. I think this there's a decent amount of logic in this, because we have to get asset distribution data. This goes and this calls, and yeah, you've got to call the node delegator now, we've got to get the asset balance of the strategy. Okay, and really quick, just something I thought of that I want to put here is malicious delegators. I just don't want to forget about that, but that's something that I want to look into. Okay, so yeah, I mean, I'm going to write that down as a finding at probably a low, maybe depending, could be a medium, but just the gas worry here. So if we're looping through all of this and we're getting all the value, this could become somewhat gas intensive. If there's a ton of tokens, if there's like 20, 30, 40, 50 supported assets, this could literally turn into a DOS where you can't execute this loop and do all this logic in a single block because it just requires too much gas, more than the block could allow. So that's something I'll note down here. So I guess I'll give this line, we're in the LRT Oracle, line 52. So I'm just going to write gas concerns over the loop, many supported assets may lead to DOS. All right, and that's our first 45 minutes. So we got a handful of initial stuff. We're starting to understand what's going on here. And what we'll do is we'll just take like a, I don't know, 2-3 minute break. And then we'll come back, we'll do another 45 minutes. And we'll see. Hopefully we can get like a nice high. That would be good. So yeah, I'll be back in 2 to 3 minutes. All right, cool. So I'll get another 45 minutes set. And also, as we're going through, feel free, any edge cases that you guys think of that we should add to goals, or anything that, comes up. And of course, any questions, like just feel free to shout them out and we can go into that. But so I'll get that started, and we're going to continue looking at this, and I'm definitely going to try to manipulate this price. Definitely. I think it can be manipulatable. Well, it definitely can, because it's based on, I know at least a portion of this is based on the balance of. So literally right here, our note that we added here, this get asset distribution data, this is going to be called when we get total asset deposits, which is right here. I can manipulate this. So it's interesting if I were to use a flash loan. The only issue is, of course, getting that money back and repaying the flash loan. But certainly in a single transaction, this can be manipulated. So we're going to be digging in on that. Let me just close out some of these extraneous files. Okay, so we're looping through all the supported assets. We're getting the asset price. Oh, interesting. Total ETH in pool. The asset amount times asset ER. I wonder if that stands for ETH ratio. I don't know what that stands for. Yeah, but I think this is the price in Ether. That's what I'm operating off of. Let's see if they have any clues. Oh, here we go. Yes, RS ETH. So they're saying that their asset ETH exchange rates. Okay, so it is indeed, this is Ether per asset. This is Ether per RS ETH instead of dollars. So we're getting the actual amount of the asset. So let's say it would be interesting to know what assets they plan to support here. I'm going to just assume like one of them is like USDC. We can use USDC as an example. And I wonder also, what if one of these assets is itself Ether? I don't think Chainlink provides a wrapped Ether price feed or anything like that. So what happens then if we call get asset price the Oracle? So I'm pretty sure if they might just make like a dummy contract that just returns 1 for this with the appropriate amount of precision. But that's something interesting. So I'm going to put that in notes. Maybe it could become a finding, if even a low or something like that. But what if the asset is Ether and we call get asset price, right? That doesn't seem to make too much sense. Okay, so really we're going to dig into this, which means going and seeing those node delegators and looking into the strategies. So of course there's this, which is just the amount of money that's in the deposit pool, the amount of assets in the deposit pool. Now we're going to go through the delegators, and I want to see actually where the delegators are added. They're added by the admin, so presumably they're trusted. There's a maximum number of them, which is good, because that's another potential DOS, as if the list of delegators was so long. Okay, cool. More notes about the unchecked stuff. Okay, then we're able to transfer to, and we have to push it to them. Okay. Honestly, another thing I'll just say is they should just use safe transfer and safe transfer from. I don't know, just a bit nicer than having to do this yourself. But that's more of an informational note. All right. So to dig deeper here, I want to understand more about this because I've seen we basically push the approved assets to the node delegator, but how does the node delegator know that they've received those assets and then what do they do with them, right? So with this transfer asset to node delegator function, we're just pushing it there and then not really doing anything else. So let's go to, there should be a node delegator contract. Let's check this out. Okay, so the same note about, I think this is the same contract that has that storage variable, so same note about storage gaps, but we are correctly initializing this stuff. Okay, it's got access control, that's good. Okay, this is where we go into the strategy. So this is where we go to the reward market. Looks like this is interesting over here. Okay, cool. So the config, that's where we actually say what the strategy is. So immediately, one thing I'm thinking is what happens when this strategy changes, right? So what if it actually seems like it could be an issue. So what if the strategy is initially one address? So here's our delegator, and they've been putting stuff into this strategy over here, which is this contract. And then all of a sudden we just switch to, oh, this is the new strategy. Are these funds that were deployed here, are those lost? Or do they have to be removed before this is changed? So that's something that we'll be looking into now. Let's see. So when we deposit in, we just give it the whole balance of whatever this is. Yeah, you know what I would expect is in the deposit pool when we transfer, I would expect them to call like delegator dot deposit, or something that immediately puts it to work in the strategy, but it looks like they're not doing it. So that's another thing that I guess would be worth noting is these assets can build up and sit in the delegator without being deployed. So that's just something interesting. Let's see. Okay. Grabbing the balance of this, sending the whole balance, depositing into the strategy. And I don't think the strategy manager, I don't know if that's in scope for this. So we're going to treat that as a completely working thing. Pretend that it just, works, it makes yield, and that's fine. So transfer back to deposit pool. Okay, so this just transfers a straight asset amount. So we've got to withdraw from the strategy before we do that. Get asset balances. Let's see. Okay, so this is where we're going and we're reading from the strategy. Yes. Okay, how do we get out of the strategy? It doesn't make any sense. We can go in. I don't see a way to get out.
Can I ask a question around the strategies?
Yeah, absolutely. Yeah.
Like this might be very dumb, but what is a strategy? Is it like an investment strategy as in you need X amount of tokens and it's going to do certain things for you, or like what is in the grand scheme of things?
Yeah,
Maybe I'm missing something.
that's a great question actually. So strategy is like, I mean, I don't know anything about their particular strategies, but in general, a strategy is usually just a contract, or at least one contract that you interface with. It could be a set of contracts that I send money to. I send, like, let's say it's a DAI strategy, and the system will take my DAI and it will go, and let's say it goes to Aave, and let's say it's, or even better. Okay, yeah, I think even better. What we'll say is we'll say it's an ETH strategy. So we put our ether in, and it goes to our our own stablecoin protocol that we are creating, right? So it goes to a CDP, and what it will do is it can take out a loan, and it can leverage your ETH for you, right? And it can either earn you yield that way, or really it doesn't actually matter what protocol's on the other end of this. It's an arbitrary like strategy for, I put ETH in and it has the logic to manage my money, deploy it into other protocols. So, you could put it in Compound, you could put it in Aave and like lend it out and then earn interest on that. And there's also like more complex stuff that it can handle for you, like looping, where in Aave, in our CDP protocol, one strategy is depositing Ether as collateral and then borrowing against that collateral and then swapping that to more Ether, depositing that as more collateral, all sorts of just different quote unquote investment strategies that you could have that will earn you yield one way or another, right? So in some cases, Aave, for example, will pay you out interest when you go and you provide collateral that can be loaned out to other people or stuff like this, right? So essentially, if you treat it as like a black box, it's a cool thing. It's like put money in, get money out, right? Uh, it's almost like a savings account or like a it's like a an
Like
investment
putting
account.
money into like yeah, asset managers or something.
Yeah, exactly. Like they're basically like money managers, right? Like a money market or something like that. And you can build a strategy for anything. So, but as a black box, it's just something where you put your money in and over time you'll get a little bit more and it will continually like compound your interest for you and stuff like that. And that's where you start to talk about like optimizer vaults. Like, for example, like we can have a look at one of the biggest quote unquote companies, I guess decentralized protocols that does this. They've got all these different strategies here. So like this, for example, Ethereum triplets. This is a strategy that underneath the protocol that it interacts with is Beethoven X, which is a an AMM where what this will do is it will go and it will take. So we can click on this. I would have to deposit this liquidity, this LP token, and then they would do whatever crazy stuff with it. I don't know what the DeFi strategy is behind this, but I would deposit this token and then they would, I think what they would be doing in this vault's case is they would just be auto compounding. So whenever I get rewards from, whatever the actual protocol is over here, you get, let's say you get some rewards in like whatever, I don't know, whatever token, TOK, whatever token. I think what a lot of these strategies do is they just sell that token for more of whatever the LP token or whatever is, and then that gets deposited back into the vault and it auto compounds your rewards for you so you get that effect.
Oh, that's cool. I think so. That makes sense. I guess the incentive is to increase the money pool, get bigger returns, and then that's all on Beefy as well. The DAO runs the strategies themselves.
Yeah.
So it's like an aggregation of everyone's minds and everyone makes money, I guess. That's the optimal point.
Yeah, it's really cool because it's all decentralized and the entire system can work even ideally without any management because the core functions that need to like continually happen is like in Beefy's case, they have like a harvest function. This is what actually does the auto compounding, which is the main service that they really offer is, taking your rewards, changing them back into the token that can go back into the strategy and then compounding that back. That's all done with the harvest function. And they just incentivize anybody to be able to call that. So it's not like you're relying on somebody to call that. You're just relying on, okay, there's an incentive for people to call this when it's the right time to call it. So as long as people continue to want to make money, this function will be called. And it's a completely open, permissionless environment. It's a public function. So like it will just continue to work naturally. So yeah, Beefy is pretty cool. But so yeah, we're just gonna treat this as like a black box of, it's just a normal strategy. If we did want to go really deep, it would be useful to probably go and look at the specifics of the type of strategies, just in case there's any sort of reentrancy potential or DOS potential. But I don't think we're gonna get to that today. Okay, so let's see. So I see all of these ways to get money into the strategy. So you can deposit into the strategy. I have no idea how you get money out of the strategy. So they do have this transfer back, but that just takes the asset. That's not a way to exit this strategy. So what the strategy will do, it will actually take the assets from this contract and then it will be in the strategy system. And to get those funds back, I guess if we look at the interface for this, yeah, on the interface, they literally don't even have a way out. So let me read this. Shares, you want a new shares. Yeah, it'll return shares, which is kind of like your ownership of the total pot that the strategy is holding. Interesting. So yeah, I don't see a way out, which is a bit confusing. I wonder if there might be something that's probably specific to these eigen strategies, is there's got to be a way that these delegators are, they probably turn the strategy off and like push those funds back. And then that's when this transfer back would happen. But okay, so I don't want to lose this string that we were on where we switch the strategy. So yeah, okay, I'm thinking of something interesting that can happen here. So when we get the asset balance, we are thinking about the strategy. So let's see, the strategy manager. Interesting. So when we deposit into the strategy. Now we get a list of strategies on the other end. So this is weird. Also, there's like 4 different for loops that we have to go through. So DOS is probably definitely a consideration at this point. Okay, so a list of strategies by the strategy manager. Okay. So it looks like this is their way to address that potential issue of changing strategies. Yeah, so I thought we were going to be able to get them. What I wanted to happen was I wanted them to have this issue where they only value whatever the current configured strategy is. And then as soon as they switch strategies and they start using a new one, then they just forget about the funds over here when it comes to getting the asset balances. And then what that would cause is if we have a chart of time and let's say just value locked in the system, we would say, okay, so there's this much value in the system, there's this much value, it's just a constant amount that's supposed to be a straight line. And then at a single block, there is a transaction that changes the strategy. And we switch from this strategy where all of our money is for this particular delegator to a different strategy. And then we're not tracking all of the money that was previously here. So let's say if there was 5 ether here, then immediately in a single block, in a single transaction, we lose that value. And so right here, this delta, this is 5 ether, right? This is the amount that was no longer, oh, I got this big box around it. Okay. This is 5 ether. This delta right here is 5 ether. That's the amount that we're no longer tracking. And so when we have a stepwise decrease like this can actually be gameable, I think, if I were to, so in this case, what I would want to do is I would want to sell or get out of whatever this RS ETH is, which I'm not even sure that you can do, but that's another thing entirely. And then you would want to buy back in when this happens. And this is sort of a mispricing. And then you would basically glean that delta of value, but they actually avoid this issue. So what they do is instead of just checking that one configured strategy when they're valuing stuff, they get every single strategy, which means that they have to spend a lot of gas to do this, which just makes this one DOS function, it makes this finding probably a lot more valid, but it means that that's not an issue. Yeah, so they're looping through all the strategies. Interesting.
Would it still be, sorry,
Oh no, go ahead.
would it still be a problem if they lock you in so you can't trade out and back in, kind of like this? But you still lose, though there's still a difference of 5 ETH, right? But is that just like the price of changing strategies? Or what do you think of like if they lock you in? That's still a problem, still bad.
Yeah. So from what I'm seeing here, and I'm assuming this is something I don't know about the eigen strategies, is seems like there's no way to get out of the strategy, but yeah, definitely if it's the case that once you deposit into the system you can no longer withdraw, I would think that's not a feature. Like, I don't know. But yeah, I would say yeah, it's definitely an issue if when they make the switch, they can no longer withdraw from this strategy. That's certainly an issue, but I mean, as of right now, I don't even see a way for them to withdraw from any strategy at all. So that's something we're probably going to have to actually dive into the eigen strategies to look at those a little more closely, even though they're technically out of scope, but just to understand how this is happening. But on top of that, they actually do have this get asset balance function. So this is for a single, this is the balances plural. So I'm going to go back to the deposit pool and I need to read this function again. The deposit, no, I need to read this one. Ah, perfect. So they're using the singular get asset balance function. And if we go to that, we can see the singular get asset balance function. It does have the issue that we're looking into, where as soon as we change that strategy, now all of a sudden we effectively lose all of the value that was deposited here in terms of what is being tracked. So we do have this issue. Now I need to understand more about how it's certainly an issue, probably a high, maybe something critical if I can understand more about how people withdraw funds from this system. But that is definitely an issue. So I'm going to write this down. So we are in the node delegator, and the line numbers related to this that I'm going to write down are, let's see, this one right here, line 59, and then this one, 122. And so this one's kind of interesting. So I'll actually take some time to write this one out. So let's start off with just some information about in the node delegator. So we'll say the node delegator contract tracks the balance of assets deployed into the, we'll say, configured, how do you spell eigen strategy, into the configured eigen strategy that is currently configured in the LRT config contract. Tracks the balance of assets deployed. However, the strategy configured with the asset strategy can be changed, or at least I've been assuming that it can be changed. I'm pretty sure it can be changed. So we'll just go to the LRT config. So the asset strategy mapping. Yeah, so there is an update asset strategy where you can change it, right? It can be changed with the LRT config.update strategy function. In the event that funds are deployed in the current configured strategy and the strategy is updated, those configured, those previously deployed assets will no longer be tracked by the, see, what is this function called? Get asset balance function. Get asset balance function, which will ultimately cause a mispricing in the Oracle, mispricing of RS ETH with that function. Okay, so and then of course our recommendation would probably be, so we have to understand if this is, there's a chance this is a medium, if it's just something where they have to manage it correctly, they have to be sure to handle all of that. But I think there's a good likelihood that it's a higher critical. So at this point with what I know, it would be, there's probably going to be a code change. But okay, so we do definitely have to know more about these eigen strategies before I could say whether that's a medium or a critical. So let's have a look. Let's try and find these eigen strategies. I guess I'll just go ahead and look up eigenlayer. I've heard of it. I've never looked at their code or anything. Interesting. Let me find their GitHub. All right, so I'm gonna just clone this really quickly. Okay. Let's see what we got. There is core, strategies, strategy base. Let's just have a look. Okay. Deposit. Okay, so the functions we're interacting with in Kelp are deposit into strategy, strategy manager. Okay, so this is a permissioned, only the strategy manager interacts with this. So this is like this is a very common setup with these like vault strategy patterns, is you don't just have a strategy contract, you've got a vault interface contract. This is everything that people interact with. This is how people deposit and withdraw from the system. And there's a separate strategy contract, which is concerned with the actual implementation of going and putting these funds to work on some other protocol over here, or in this case, actually going and staking this ETH and managing the staked ETH. And so this is usually called a vault. This is the strategy. Then users will deposit here, funds will go here, and then they'll put that to work in the strategy. Users will make a request to withdraw. Then this vault will have the permission to withdraw from the strategy and then give that money to the user. So that's what the setup is looking like here. Let's take a deeper look. So I want to find the strategy manager because this is all great. We can see the withdraw function, but it's all permissioned. This is not what we're actually interfacing with. So I think we'll go here. Here's the strategy manager. Okay, here's the function we are calling, the main function we're interested in. So we're going to go into this internal function. Once again, we'll see, safe transfer from, first thing we want to do. Okay, then we're actually calling the strategy. Yeah, it's very interesting, just as like a design note, the fact that with this kelp node delegator, we're sort of reaching into the internal logic, like the vault strategy pattern. This is meant as sort of like a nice clean abstraction where this is the interface that you get and you don't worry about anything about the strategy. But what we're doing here is in this get asset balance function is we're actually calling the strategy directly, which is usually in these systems it's not, you want to be calling only vault functions if you're integrating with this system. You don't want to be going over and into the abstraction and directly interfacing with the strategy. So that's something interesting. Delegation, increase delegated shares for the staker. Interesting. Okay, so I'm interested in getting out of these strategies now. So because that's what we're confused about. So I see deposit in, deposit with signature. We've got remove shares, only the manager, right? So this is probably why. And I'm sure if I knew more about eigenlayer, I would understand why. Yeah, so the manager, let's see who the manager is. Delegation manager, right here. So this probably has to do with all the details of, when you can unstake your ETH and stuff like that. So let's see. I want to we'll just grep this file and find out where they call one of these remove shares, dot remove shares. Yeah, so this internal function gets called undelegate staker, and then I'm assuming there's got to be you've got to be approved. So somebody's got to be the operator. So I think this is what's happening is there's an operator configured for each of these node delegators. Now we just have to be sure that they are able to configure this operator. I haven't seen them configure that. So let's see how those operators. Oh no, this operator, yeah, the delegation approver. Oh no, I think this is all centralized on eigenlayer side actually. Oh no, they can configure this. Okay, so let's see where you can set this delegated to. Delegate to an operator. The address to delegate to, they give power to place the staker's assets in these strategies. They handle withdrawals and stuff. So we delegate to, interesting. We've got to make sure that they're setting this delegated to appropriately. Max approve. Yeah, that's just, that's fine. I'm not sure when they're going to be setting that though. Because if you just call, the only function I see them calling in the eigenlayer system is deposit into strategy, right? The only interfaces we're using here, the only time deposit, get deposits, which is a view function, presumably. So deposit into strategy, this isn't going to set any kind of operator. So yeah, I mean, I'm just going to add this as a finding, and this is the way it seems right now, is that in the node delegator, really just everywhere in the node delegator, there seems to be no way to configure the operator for the node delegator. Let me check these abstract contracts. This always gets me, actually. No, I mean, let's check the LRT role, config role checker. I don't think that's going to do it. No. No, it looks like there's no way. So, okay. So there's no way to configure the operator for the node delegator on the eigenlayer side, which means there is no way to withdraw the RSETH, or not the RSETH, the deposited assets from eigenlayer, withdraw slash undelegate, right? If we just have a quick look at deposit into strategy deposit. Oh, here we go. Delegation. What is this? Entry staker strategy. Let's see, what's the interface for this thing? That is the manager. Okay, hold on. Now that's interesting. Increase delegated shares. See, but where is that operator set? Yeah, it won't be delegated. All right, that is 45 minutes, but yeah, that seems like an issue. I really think it's something that we're missing, but I don't see what we could be missing. So I mean this would be something just critical. I mean that's the number one issue I see. So a recommendation would just be to add a way to configure the operator for the node delegator so that funds can be withdrawn from the strategy. But I think for this we just need to understand more about this system. Like why am I only able to put stuff in? And it doesn't seem like there's a way to get out. So yeah. So that's yeah, basically the first 90 minutes of a review here. We got a few good findings. Probably a high here. Seems like a basically just a critical, I don't know. All right, so while he's setting this up, I guess we'll just cover the baseline context for this system, as I know it, is essentially what's happening is, of course, we have this idea of staked ETH. You can stake your ETH to secure the Ethereum network and get some interest, staking rewards for that. Now, the next sort of fundamental thing we need to understand is this idea of restaking. So you have your staked ETH, you're securing the Ethereum network, and now you can restake your ETH and secure other networks as well. So if somebody wants to come in and they want to build a new proof of stake chain or something like this, those startups have a huge barrier to get, capital to secure the network. So what they can do is they can sort of leverage something like Eigenlayer, which will allow them to restake which will allow staked ETH holders to restake their ETH and secure both networks at the same time and basically get the Ethereum staking rewards and this new network staking rewards. And that is what this idea of restaked ETH is. And so what Kelp is doing is they're making these restaked ETH tokens liquid. So you can deposit your staked ETH into this protocol, and I believe that's what we'll see with like the RETH. I think that's like Rocket ETH, and Rocket is a staked ETH provider, kind of like Lido or something like this. And then those will get deployed into Eigenlayer, and through this deposit pool and owning these RSETH, you have a quote unquote liquid version of these restaked ETH tokens. So that's a little bit confusing. There's a lot of moving parts there, but that's a high level of what I understand at least this system to be doing. But with that out of the way, Priyam, I think you already had the chance of looking at this code base. So I guess what's your level of familiarity here?
No, actually, I was planning to start this audit, but then I had something else to do, so
Yep.
I have as much knowledge as all the other guys.
Okay, cool. So what we'll do then is let's start off and first of all let's identify some goals that we want to start off with. So I think I'll go ahead and track the goals. I'll just write them up in this chat here. So I'm typing in the chat and I'm going to say, first of all, I think we should have a look at, we should just walk through the basic flows, right? So deposit into the pool, that's the first one I'm going to put there. And let me know if you can see what I'm typing there. It's in the chat for the actual call. It's a little bit hard to get into.
Yeah.
Okay, cool. Yeah, so right there, deposit into the pool. Let's see, what about deploying the RETH into Eigenlayer?
Or we can write it here in the notes that Graham has.
Yeah.
Yeah. How about that? And yeah, you can just copy those over. And folks, go ahead and shout out like what goals do you think we should have for this based on what we know about the protocol?
How do we CRUD stake ETH? Like how do we like mint it or deposit and withdrawal?
Yeah, so how do we actually get staked ETH?
Yeah.
Yeah, so I think from the point of view of this protocol, they're expecting you to already have the base staked ETH, and that's actually what you deposit into the system.
Oh, okay. So then how do we deposit would be a feature.
Yeah, yeah, absolutely. And yeah, that's so how do we take our staked ETH and put it in? I see a good one here for from Hendrik. How are the rewards calculated? That's a good one.
I think that given that they are depositing take it into strategies, they must be tracking the shares.
Yeah, through tracking the shares. Yeah, we'll see exactly how that works. That's a good one. Yeah.
How are the reward splits normally with the like restake tokens? Because obviously, like let's say I have like 10 ETH staked, and then I want to restake like 5 ETH. How does it like affect your APY?
I think it
And like,
depends.
why would someone even do this? Is it for like higher rewards for like more risk?
Yeah, so what happens is you'll still get the same rewards that you would get from staking for Ethereum mainnet. You will also get on top of that the rewards from, whatever extra network you're staking across.
Interesting. And obviously increases your chances of getting slashed, right? Because if that network gets slashed for doing something dodge, then
Yeah, exactly. So it's
okay.
a risk to reward type thing.
It's always just like that first like journey is always like to figure out the why behind the stuff. Because I feel like
Yeah.
you can't
Yeah.
attack
Yeah.
something if the why is the feature, you know? Like so weird.
Yeah.
Also, a quick question. How is the governance working for this? Like who has control over the locked amount or the deposited amount of staked ETH?
That
Like, is
is
it one person or is it a group of people? Or it's a multi-sig address. It's governance token. It's what?
that's a good one. That's a good one as well. It's a good goal to put. So, what kind of governance structure? We'll figure that out. And then also, I'm going to put in the chat here this article that we had last time, just because it has a good diagram in it. So we don't have to go and create our own diagram. We can sort of follow along with this one. And it looks like there is a little bit on governance there. They have like a risk committee, and it seems like governance somehow talks to the node delegator and the registry. So we'll see what that looks like. But I think we have enough goals, at least to get us started. Also, okay, I see Hendrik put in just two more, so we can grab those. And then I think we should have enough to get started. And the first thing we're going to want to do is I'm going to start the timer for 35 minutes. We'll want to, let's understand how do we deposit into the pool. Let's do that.
So I think this must be the contract. So this is the function deposit asset users stake LST to the protocol.
Yeah, so I guess maybe walk us through how do they get the assets from the message center, and then how do they decide how much shares to give you?
Okay, so in the deposit asset function, we have the modifiers non-reentrant when not paused, and I think they only support limited assets which we can deposit in this function. We have so in the function we mention which asset we want to deposit and the amount. There are few checks here. It should be greater than 0, and they have limits on how much asset we can deposit. They are trying to transfer the asset from the user to this contract. They are minting the equivalent amount of RS ETH to the user.
Okay, great. So that's where we get the staked ETH is with that transfer from. And then now that we have that, we're going to give them our SETH, which I guess is our like share token. That's our liquid token.
Yeah, so they are using this function to convert the amount to shares, I think.
Okay, cool. A lot of interesting things here. So we can see we're using an oracle, and then we have a formula here to convert the amount of tokens. So let's say that is, just staked ETH. That's the asset. Then we're converting that to uh, an Ether amount, it looks like, with the LRT Oracle. And then we're doing something to convert it to RS ETH. So I guess next probably we want to look at the Oracle for these functions, right?
This kind of seems like the CDP like that we were kind of making, right? Instead of like stablecoin, they mint ETH.
Yeah, I also think that it's similar to that protocol. But we need to figure out like in which value are they using the Ether value of the staked ETH or the USD value, right?
Mm.
Yeah, so I think there's one comment that I saw here on line 49, it looks like. And they actually say, so RS ETH slash ETH exchange rate. So I think all of these prices are in terms of Ether.
I'm guessing RSETH also has 18 decimals, so we don't have to worry about rounding errors, maybe.
Yeah, that's a great question. Usually to figure out decimals. So decimals is something I always have to figure out, no matter what code base you're looking at. We've always got to figure out how they're handling decimals. So let's go into the test directory. What I always like to do is just go check out the tests and try to understand, because usually you can tell only from the tests what decimals they expect to use. So let's go to the Oracle test. Okay, great. So I can already tell based on at the top there, those mock oracles. I can see, so they're mocking out, first of all, this get asset price function. And I can already tell based on that, the prices that they're expecting are in Ether. So that's going to be something with 18 decimals. So that's something that, we'll just kind of note and keep in the back of our mind. The prices are in Ether. And then also I'm seeing they're mocking out the deposit pool as well. And it looks like the total asset deposits function, that's also expecting one ether or an ether amount. So that is also 18 decimals. So yeah, I think you're exactly right, Max. It looks like they're just treating this as something with 18 decimals, and also the prices have 18 decimals. So those are good to keep track of.
Okay, so now we know that they are using 18 decimals. Uh, in here, they are calculating how much RS ETH should be made them. And if they are using, the like spot price exactly at that moment, we can use flash loans to manipulate it or something like that. Is it possible?
Yeah, let's see. So I guess that would depend on what Oracle they're using, right?
Yeah.
I think it's Chainlink.
Yeah,
Get
so
asset price.
yeah, let's see that get asset price function.
I
Yeah.
right.
There's a test called Chainlink Price Oracle Test.t on top.
Okay, it looks like if you scroll down a little bit.
Do you see those are the tokens that they also use in the protocol?
Yeah, I'm seeing RETH.
That whitelist.
Okay, great. So yeah, I think what they're doing is they're gonna use like a chain link aggregator, and they're just gonna wrap it in that price feed interface. So if we go back to the Oracle contract, yeah, I think this function will basically just interact with a chain link aggregator.
Okay. So if they are using the Chainlink Oracle, then it's not possible, right? To use a
Yeah,
flash loan.
it's no on-chain manipulations. Uh,
Will affect the price of.
yeah, yeah. Now, I will say one interesting thing to think about with Chainlink Oracle updates is actually, so the way that Chainlink works is it's just a smart contract that gets updated by the Chainlink network every 30 minutes or so, or it depends on the feed. One interesting thing that you could do is you could front run and back run the price update. So there's some transaction that updates the price in the Chainlink contract, and so before that transaction, the price will be, e.g., $100, and after that transaction, the price will be $101. And sometimes you can front run and back run that to, you know, extract some value from a protocol. But I'm not sure if that's going to yield anything interesting here. But just a note.
Yeah. You need a lot of money to do that, for arbitrage trading.
Yeah, if it was a small price update, and the arbitrage was like only a number of basis points, you would need a lot of money. But you can also you can't really flash loan because it's across two transactions. So yeah, you do need money to exploit a small arbitrage and make it valuable. But yeah, sorry to interrupt. So you're looking at basically the conversion from the deposit to RSETH.
Yeah, here's the conditions. So this amount will get minted to the user. Now, now we need to figure out what are they doing with this amount, right?
Yeah, so it seems like the user just gets that amount, and then this contract gets their staked ETH. Is that what's happening?
Yeah. So they have transferred the amount to the, what is the function? They have transferred the amount in this contract.
Yep. Okay, yeah, I think that's pretty much our first goal, right? we understand now how people deposit into the system, they get minted RSETH.
Which transaction updates the user's balance? Missing it.
Balance of which asset?
The minted assets. Is it mint? Is it in the mint? Let's see.
Yeah, so I think we see it right there
Oh
on
yeah,
line
there.
156. Yeah.
Yeah.
Yeah, so that's how they get minted. So I guess what is our second goal? Okay, yeah, how do we move the RETH, so the asset that gets deposited here? Now we have it in this contract, but as we know, the ultimate goal of the system is to deploy that RETH into eigenlayer. So I guess how does it move into eigenlayer? And here it might be useful to refer to that diagram actually.
Diagram doesn't really go over it.
Let's see. So I think so the restakers, those are the users. They put those assets into the deposit pool. That's what we just looked at. And then yeah, I think what you're looking at right now, that approved assets arrow to the node delegator. I think that is how we actually put stuff into eigenlayer. So I think we need to find exactly that function right there, yeah.
Yeah, so those approved assets are like, do we know like which ones they are? Because I was looking at the test, there was some deposit asset with the ST address itself.
Yeah, I think there's, so you're talking about which assets are used with the protocol?
Yeah, in the test, they sometimes they deposit RE, sometimes they deposit ST.
Yeah, I think what our ETH is like Rocket ETH, which is a I think it's Rocket Pool or something like that. They're a particular staked ETH provider. So you can stake your ETH and get a liquid staked ETH, which is our ETH, and then similarly ST ETH, that's another similar version. I think that's Lido. Um,
Yeah, like
yeah, so
okay.
they're pretty much interchangeable. It's just different providers for a liquid staked ETH. Yeah.
Oh yeah, I see it now in the base test. They have ST, RE, and CB.
Okay, cool. Yeah, so we've got this transfer asset to node delegator function.
I actually have a question about the only LTR manager. So let me just pull that up.
Yeah, let's do it. Let's have a look. See if we can figure it out.
What file are we in? LTR
In the
T
deposit pool,
LRT.
that was the one we
Awesome.
were looking at.
Okay.
Yeah. Yeah, that's perfect.
Yeah. So there's a LTR manager or LRT manager, and then there's also an LRT admin.
Okay.
Um, so I'm just curious where those modifiers are and kind of who has control over what in the system.
Yeah, let's find out. Okay, so
They
we're
can
not seeing it
pause.
there. Let's see at the top of this contract. Let's see what this contract is inheriting from.
Yeah.
Okay, so it is right there.
Utils or config role.
Yeah, I think it's that one.
So it's much. Default admin role is just 0. That doesn't sound like great.
Yeah, so this is
Because I
like
might lock some things.
yeah, this is like a role-based access control system. So that default role is basically just like the the
Starting
basic.
value.
It's like the basic admin. So if you want to assign somebody to a basic admin, they have to have OX00 as true, and we can actually we can look at the access control. So if you scroll up to the imports here, uh, you might have to install stuff, but what if you can go there? Okay, no,
Yeah.
I'll pull up. Well, basically,
Well, let me see.
yeah, basically in that
Actually,
access control, yeah, I think you should just have to forge install, and then you'll be able to.
Yeah.
But basically, in there, there's a mapping from, uh, essentially from the bytes object, which is what we saw like OX00 is one of those.
Okay.
Maps to a Boolean, right? To say, do you have this role, right? So each of those bytes32 objects is like a quote unquote role that you can hold, and one of those
Okay.
is the default admin role, which is just a key with 0, right? And so if you set that to true for an address, they are the default. They have that role. Yeah.
Okay. So only the admin can update configure role. So it looks like pretty centralized. I don't know if that's a security thing, but if there's only one user and that's not a multi-sig, then I would be concerned.
Yeah, certainly it should be a multi-sig, and I don't know if the governance stuff is in scope for this, but it might even be.
I think it is. They just wrote out that the open sapling contracts aren't in scope.
Okay, yeah, so uh, maybe we'll get to that. Maybe we'll be able to look at their governance module if it's in here. But yeah, basically, centralization might be something. Um, but yeah,
Okay.
basically, that's what the modifier there is doing.
Okay. So where are we on goals?
Yeah, so we were, yeah, I guess that's why we should have probably left them in the chat. But we were looking at how do we get them from this deposit pool into the operator, which is where we're going to actually put them into eigenlayer. So I guess let's do that. And
Do
also,
you mean,
yeah,
is that the node delegators or?
yeah, and the node delegator, but there's a function in the LRT deposit pool that we were looking at. I think if
Oh, okay.
you scroll down
Get node queue, access distribution, deposit asset. No, we went over that.
a little bit
Let's
further
see.
down,
Add node delegator contract to queue.
the one after this,
Okay,
this one.
transfer asset to node delegator.
Cool. And
Yeah.
thanks, Priyam, for sharing the goals there. Okay, cool. So here, I think this is the function that's making the transfer. So maybe let's walk through and let's see what this does.
Uh, it doesn't appear to be. So it looks like if you can't transfer, then revert.
Yeah, this is basically safe
Um,
transfer.
Yeah, it's a backyard safe transfer.
Yeah. The
okay.
it's a discount safe transfer.
Okay. Um, yeah. So let's use the. I don't know what the difference is between the manager and the admin. It seems a little
Yeah,
um,
for our purposes
sus.
right now,
But
just like understanding the core functionality, we'll go ahead and just
oh
assume
yeah, yeah,
it's like just a trusted address. There's probably some centralization issues there, but we'll just go ahead and say
yeah. Okay.
some trusted address has to call this function.
Okay. What is the NDC index? Like the index of the node delegator?
Yeah, so it looks like if you scroll up that function you were just looking at right here,
Oh, okay.
it looks like that's how they're adding what the node delegator contracts are, and that's also another trusted address. I also
Okay.
don't understand the differentiation between the manager and the admin, but uh, it is what it
Yeah.
is. So
We'll just go with it.
yeah, yeah. So uh, it looks like here this is where they're adding them, and then you can reference them by the index that they are in that queue. That's what it seems like.
How are they like? How big is this supposed to be as a protocol? Do you know? Because they have like maximums for deposits and maximums for the node delegators. So I'm just curious. Like, I'm still a little fuzzy on like the purpose of this exercise for like building Kelp DAO. Like, what does it do? Like, it gives you more rewards in like their own token, but like, how liquid is it?
Yeah, so from a high
Right.
level, what does kelp do? So
Yeah.
okay, so when we restake these tokens into Eigenlayer, and Eigenlayer is the platform that allows you to restake, your tokens are
Okay.
basically locked up in Eigenlayer, right? You can't really do anything since I've
Got
taken
it.
my staked tokens, which were liquid, right? I could go and I can use staked ETH and from Lido, and I can interact with DeFi protocols with it, and I can sell it and stuff like this. But if I take my staked ETH and I put it into Eigenlayer, Eigenlayer has my staked ETH, and I can't really do anything with that. I'd have to withdraw from EigenLayer to be able to, you know, sell it or do anything like this, right? So what we do with this protocol, it is basically it's kind of like staked ETHception, like liquid stakedception, where you take the liquid stake token, you put it into EigenLayer, and then now it's a liquid, so we need to make it liquid again. So
Okay.
what this protocol
So
does,
getting like double rewards, like getting the staked ETH rewards on like Lido or Rocket, and then also getting the Eigenlayer rewards, and then
yes,
still having something that's liquid.
exactly. So EigenLayer basically
Okay.
combines the rewards from staking with Lido and staking with another chain, or whatever that looks like. We don't have to concern ourselves with that. But the
Okay.
downside of EigenLayer is that, well, now my token's illiquid. I would have to withdraw it to use it. So this protocol is giving you a liquid version of something that's in EigenLayer, if that makes sense.
Okay. Yeah. It's like getting more leverage.
Yeah, exactly. And increases composability where now I can use this in other DeFi protocols and things like this.
Right. I'm just curious, like why they have maximums.
Yeah, so that looks like a max on the node delegator count. So um,
Yeah.
that's like, so for each node delegator, that'll be a different contract that's like managing funds that are deployed in EigenLayer. So they're saying like,
Okay.
okay, uh, you're not allowed to have like 500 uh, node delegators registered in this queue. And I suspect the reason for that is if you scroll down,
Yes.
yeah, it's gas, right? So let's scroll
Mm.
down to
Okay.
the, yeah, I mean,
Yeah,
right
there's
there we
another
can see there's
function,
a
get
queue.
asset distribution data, which also
Yeah. It
loops
looks
through
like,
the node.
oof. Yeah. Okay. That would make sense then. Block class limit hit. But the maximum
That's why.
deposits, I'm just like, why would they do that?
Yeah, so the maximum deposits. So I think EigenLayer actually itself, they might uh I'm not sure, I'm not
Oh,
actually
okay.
really familiar with EigenLayer, but they might. And also uh a deposit cap is actually something that we implemented in our DeFi protocol when we were first launching it, because also you want to mitigate the total amount of funds that are potentially at risk. When you're just first getting a DeFi system out there, you want to take it easy, right? You don't want $1 billion in
Yeah.
there tomorrow. You want it to get battle tested and very slowly allow things to move up. So that's also another reason they might have a cap there.
Okay.
There's one
At
question
least
I had,
I'll go for it.
or like point I'd like to bring up. So somewhere in the code I saw like, well, I don't know if this is valid, but somewhere in the code I saw like the admin can change strategies and stuff. So at first I was thinking maybe there's like a withdrawal problem, like they change strategy, but then I'm thinking obviously they can just change the strategy back to the old address. But I mean, I don't really, it's been one of our goal, like how they mint shares and stuff. I was wondering if the shares like will take account of all the strategies, or for example, like if I put something in strategy A, will and they update a strategy B, will all my money be moved to strategy B accordingly, or like do they have like a migrate for that or something like that? Or will my funds get stuck in strategy A, or my shares like from strategy A will not get accounted, so like I'll get like some bad RETH or some bad liquid LP tokens or something like that. You guys, does that make sense?
Yeah, 100%. Yeah, I think and I think that's a veritable issue because like we'll see, so we saw funds getting transferred into the node delegator. So now we can open up the node delegator contract. And what Saeed is talking about here is in, let's see, deposit asset into strategy, we can see that on line 59, there's a configured strategy for whatever the asset is, right? So if our asset is staked ETH, ST then there's a configured eigenlayer strategy, or there might even be other restaking platforms, so it might not even be eigenlayer. You can configure it to a different provider. So what Saeed is saying is, if we're tracking our deposits by referencing whatever the currently configured strategy is, then what if we change what the currently configured strategy is? And then will we just lose the money that is deployed into that old strategy? And I think that's actually a valid issue from what I'm seeing.
So it seems like only admin can update the strategy.
Yeah, only the
What
admin
I
would be
saw.
able to update the strategy, and I think that would happen in the
So the user
LRT.
can't.
Yeah, in the LRT config file. Yeah, right there. Yeah, exactly. This function.
Yes.
So that is only the default admin role can actually update. So it's not something that a user could do because that would be catastrophic. You just update it to like some
Yeah.
bunk strategy and you've just lost everything, right? But so that's a risk, right? It's a centralized risk somewhat because of course only the admin can do it. But it seems like if you change the strategy, if we go back to the node delegator contract,
Yeah.
in here, the way that we're measuring the value in here, so I guess if we scroll down a little bit more, get asset balances, or actually let's go down one more, get asset balance. So this individual function, this tells you how much balance is belonging in the strategy. So we get the configured strategy, and then we return we call the strategy, and that user underlying view, that's a really terrible name for what balance is deployed in this strategy. So if we change that strategy, it seems like we just lose the balance that we had previously deployed in the old strategy. Does that make sense to folks?
Does the strategy actually change the balance? Well, yeah, it's multiple strategies, though. So I guess, yeah, no matter. Answer my question.
Yeah. Yeah, so I guess that's maybe just leapfrogging a little bit ahead of where we were, but let's go back to the original function we were looking at in this file, which is deposit into strategy or something like that. Yeah, this one. This is the main one. So just to set the stage, what we've done so far is we've deposited into the LRT deposit pool, and then we've seen that there's a function that's called by some trusted address that sends those deposited tokens to this node delegator contract. And now my intuition is saying that this deposit asset into strategy is how we go from the node delegator now into eigenlayer. So I guess, Max, do you want to walk through and we'll just go line by line in this function?
Yeah, sure. So it looks like the address of the strategy is somewhere in the LTR config, and you have an asset strategy with a specific asset. And then that asset is in ERC20. So then you grab apparently there's an eigenlayer strategy manager address. So they grab that. That's constant from the inception of the contractor. It is native to eigenlayer. Grab the balance of this contract or this delegator,
Okay, this is
guessing,
interesting.
or is it in the address itself of this specific contract?
Yeah.
It's transferring the entire balance over of the entire contract. Like,
No, it's just grabbing the balance and then emit asset strategy. So let's take a look at this.
and it's just
I think it's depositing all of the. It looks like it's depositing all of the balance, which is all of the token. So apparently you don't get to choose multiple strategies.
yeah, this is weird. This might be like, we might be getting ahead of ourselves, but this might be why they have like the single strategy transfer. So maybe it's like one match one. I don't know.
Yeah, so at any time it looks like uh, there can only be one configured strategy for the asset, right? So on line
Yeah.
59, whatever the
Yeah,
asset is, that's just one strategy that gets returned always, right?
yeah, yeah, because it's full balance of the entire delegator, and that's the entire asset.
Yeah, it's not like a balancer pool.
That's weird.
Um, yeah, it's kind of like a little bit liquid, I guess, if you can do an additional strategy, but if you can't do multiple strategies, that's a little strange. But also simpler. So I guess that works. Um, okay, so then next on goals, like what do we? Sorry, I got distracted.
Yeah, so I think that's pretty much our we've covered depositing into the pool. Now we've just looked at what we've seen right here is deploying the rETH or the stETH into EigenLayer. So we've seen that. That's our
Yeah,
second goal. Now, uh, let's talk about how are the rewards tracked. That's the third thing here.
So because like we don't have any scope, like the eigen strategy manager and the strategy is out of scope, like we just assume that it was deposited. That's it, right? Like we just assume that it was deposited correctly.
Yeah, so it looks like these. So yeah, that's a good point is that the flow of depositing into the pool and actually going into EigenLayer, those are split up into two different transactions, actually three different transactions. So first of all, the user calls that deposit function right here that we're looking at, the user calls deposit asset, and then the admin, some trusted address will have to come in and call on the deposit pool, they'll call that function that transfers to the node delegator. And then the third transaction is that the trusted address calls the function on the node delegator contract that deploys, just sends all of the balance of that contract into EigenLayer. So yeah, it's interesting that it's split up into three transactions that way. So it doesn't when a user deposits, it doesn't immediately go into EigenLayer. And I think that's on purpose because I do happen to know that the EigenLayer contracts can be paused, like they can pause deposits. So that might cause issues for, if people still want to deposit in here. Maybe that's why they made it two-step. Um,
okay, so like third party risk of eigenlayer pausing their contracts, right? Or pausing deposits.
yeah, there is that risk. I mean, if I'm thinking about it, like maybe it's fine to let that revert if it was paused anyways, but it seems like their
Yeah.
decision has been to split this up into only allowing the admin to move stuff into EigenLayer, which I mean, maybe that also helps them in terms of if they need to upgrade, change strategies or something like that. They're the ones controlling the control of funds. So it's a lot less manipulatable. There's a lot less attack surface because the user can only really do one thing. They can just deposit it into that deposit pool and they can't really manipulate much else than that.
So, like, I have a question. How can the users withdraw back their stake deed if they want to?
How do they withdraw from the
Or
system?
even, yeah, and also like claiming the rewards. Like, where are those functions?
Yeah, it's a good question. I
Yeah.
have no idea how you do that here. Like that, I legitimately cannot figure that out. So I think in the flow chart that's in that article, there is a withdrawal manager.
But it's not in the scope, I think.
Yeah, and I think what's happening is the withdrawal manager contract is not in the scope of what this audit is. Like they haven't provided anything to do with withdrawals. So I'm thinking that the contracts here only meant to get funds into the system. And then I'm thinking they'll probably have like a follow-up scope for an audit of a withdrawal manager, which is responsible for allowing people to get out of the system.
And I also think the calculation for rewards is in the reward market, which is also out of scope.
Yeah, but also, so there is something to focus on though. So our next two goals are how are the rewards calculated and what is the shares tracking mechanism? I think both of those sort of go hand in hand. So I think it would be we still have enough in front of us to figure out how are the RSETH, so these are the shares of this kelp. When you deposit in a kelp, you get RSETH. How is that valued, right? We do have enough information in front of us to look at that, and we can actually glean what the rewards are based on that. We just can't withdraw the rewards or withdraw anything from what we have in front of us. So let's answer that question. Let's answer how are the shares tracked? So I guess we'd probably start off with deposit.
It looks like we
Yeah,
go
it's
to the
tricky.
mint.
It's tricky because like people
So
users deposit different like assets, but they have the same share. I guess like I don't know if they should be able to withdraw the same asset that they deposited.
Yeah, that's another good question. That's definitely something I would look at when they do put up that withdrawal manager is you can deposit one asset, but you still like if I deposit ST ETH, if I deposit RETH, I still get the same RS ETH shares back. So yeah, that's definitely
Yeah,
interesting.
exactly.
So it looks like the calculation is here when they decided how much to mint, according
Okay.
to the amount. I'm assuming the amount is also in like 18 decibels, like everything else.
Yeah, we're gonna have to
Um,
assume that ST ETH, RETH, whatever supported is always 18. That might honestly be a low
yeah.
finding, which is like
So,
it's incompatible with I don't know if anybody has made a liquid staking token that has anything other than 18 decimals. That would be truly devious. But if somebody did that, then it wouldn't work.
yeah. Oh, I just meant like the user might do an error or do a bad thing with that, like not get the intended amount back, which would just be annoying, a bad for user experience. So,
Yeah. I
um,
mean, you could say that really about any smart contract system. We'll just have to
yeah.
assume that the front end converts to the right decimals and stuff like that.
Okay.
so about that, the front end filtering, like how much time in what scenarios do we assume that the front end will do the things correctly, or we should put it as an issue?
Yeah, that's a good question.
Yeah, so in terms of getting the token decimals right, that's something we would assume that
Okay.
somebody interacting with the smart contracts is just gonna get right. And also, if you do get it wrong, then like, well, you're just minting a really small amount of that token, or you're minting a way too big amount of that token, and the transaction fails because you didn't provide enough assets or something like that. So that's like,
Yeah.
if the user can do something wrong and it has a bad outcome for the user, that's something that would probably be called out. So, like, the famous one is, of course, having zero address checks. If I can
Yeah.
make an order and accidentally provide the zero address as like the receiver for the output, that you should think about limiting that, right? And that's a good low informational finding, especially if the front end like just happens to mess up and put a zero address in there. That's, yeah, I think that's a good example of when it should be limited.
So we can make it that way if the user is getting affected a lot, or maybe if the user input can cause a lot of harm, we can add checks in the contract. Otherwise, we can just trust the front end if the impact is not that much.
Yeah, if it will just revert if they provide bad input, that's pretty much the delineation. Is like if the worst case is a revert, then like okay, that's fine. But if the worst case is lost funds, then yeah, you might want to consider adding a check.
Got it.
Yeah, so let's go back because Max, you were pointing out that line. I think that's a really important line to look at.
Which line? Oh, this line?
Yeah, this formula here. So let's maybe walk through this formula a little bit closer.
Okay. So let's assume that we're doing like one stake ETH or whatever, and then
Yeah.
it's worth $2,000 or something. This is interesting. So the RS ETH price would be parallel the ETH price, right? Or would that be different?
Yeah, so
No, I think the RSH price is variable. It will increase as the users add assets to this pool. And given that these assets are deposited into the strategy, they are earning the rewards, and which will lead to increase in the price of RSETH. Because
Okay.
the we can assume like the rewards are being added to the underlying balance, and that's how the price of RSETH increases. And you need more RSETH. No, like if you deposit like one Ether and get back one RSETH, after some time, as the rewards accumulate, when you deposit one Ether, you can get 0.8 RSE because the value is increased, right?
Yeah, yeah, exactly. So uh, that RSETH price, this is how we're valuing what is the value of an RSETH, right? What is the value of one share of this of this protocol? When you deposit in, you get a receipt token. This is your liquid token. This is RSETH. What's the value of that? And this function right here will answer our question of how are the rewards tracked, right? Because you get rewards by holding an RSETH and being able to redeem it for more with the withdrawal manager, which we can't see right now, but this is important to see how's everything valued. So there's a lot going on here. Let's walk through from
Yeah, there is.
let's take it
Okay.
line by line.
So token address is constant in the config.
Hmm.
We're getting the total supply. The total supply is 0, return 1 ether. Why are we doing that?
Okay, yeah, let's focus in here. So if the RS ETH supply is 0, what does that mean?
Yeah,
It means that
starting
there's
with
no way
one
to get
ether.
the
The
price,
price of
right?
yeah, the starting price of RSETH will be 1 ether.
Okay. Declaring a total ETH in pool. So is that the liquidity of RSETH? So like the amount of staked ETH total in aggregate?
Yeah, so we're just declaring this up here. It's going to start off as 0, and then it looks like, yeah, exactly. This
Yeah.
will be. It looks like we're tracking what is the total like ETH value of everything deposited in the pool. That's what it seems like.
Okay. We're grabbing the pool address for deposits, which is the pool. So um, then we're taking supported assets, putting them in an array that's dynamic, memory, supported asset count, counting the supported assets. I don't know why we're doing that.
Okay, what are the
Yeah,
supported
it's
assets?
like
Okay, now I see
I
it.
got it. It's like we are just circling through all the assets we have. The total amount of those assets, we are multiplying it by the price, and then just adding like how much ETH we actually have. And when we divide it with the supply of RSETH, and this is how the price of RSETH will increase. Like more assets in the pool, uh, more the value of RSETH.
Yeah, yeah, I think you nailed it. We'll take it line by line
So,
just so we can break it
so more
Okay,
assets
okay.
Yeah,
in
I
USD or in
count
Ether
these
price,
units.
right?
down. All right,
It's an Ether price.
let's go one at a time, guys. Sorry.
Yeah, sorry.
All right,
Um,
first of all, Felipe, what did you have to say?
Oh, it's good to check the units because like the total in the pool, if in the pool is total asset amount, I guess it's 18 decimals times the asset price. I think this line looks a little bit weird.
Yeah,
Like the
we'll
total.
we'll get to
Okay,
the units in a
okay,
second.
yeah. At the end they do divide, but yeah. Mhm.
Yeah, I think there is definitely something to dig into there, but Max, let's start first of all, what are the supported assets?
so that would be RSE or staked ETH and R ETH, right?
Yes.
No, actually, if you
Maybe.
see the config, we have staked ETH, R ETH, and CB ETH.
Yeah, yeah. So,
CP
yeah,
ETH?
I think you got it, Max. I mean, they're basically just different types of
Yeah.
like staked ETH.
Yeah, we have three supported assets.
Yeah,
Okay.
great. So those are the
Um,
supported assets. Now, it looks like we're looping through them. So what are we doing in this loop
yeah.
for each one of those?
So we're grabbing the address of the supported asset, and then getting the price of that asset, then calculating the total deposits
Yeah, this is an
of that
important
asset.
function. That's an important function there. We'll dig into that
Yeah,
more.
I want to dig into that. And then total ETH in the pool is total assets times the asset price. Um, increment the index, go through it again, and then total ETH in the pool divided by RSE supply to get the price of one RSE.
Okay, cool. So let's summarize and then we can get into, closer up details. Just like Priam said, we're looping over all the different types of staked ETH, different providers, whatever. And we're getting the price of those staked ETH tokens in Ether. So on line 68, that's exactly what we're doing. We're getting the asset price. And we'll remember that when we get price, it's not in dollars for this system. They're getting an Ether denominated price. So they're asking for our staked ETH, for our ST ETH, how many Ether is that worth, right? So we're getting that price, and then we're multiplying that by the staked ETH asset amount, and we're adding that to the total ETH in the pool. So at the end of this loop, total ETH in the pool, that's going to be what?
At least one ETH.
Yeah, ideally, but what are we basically summing up when we go through that loop?
The amount of ether in the liquidity that's being held on like the eigenlayer, right?
Yeah, exactly. And not just an eigenlayer, uh, in whatever is returned from that get total assets function, right?
Yeah.
Yeah, exactly.
So do you want us to dive into that
Yeah,
now?
yeah, the assets which are deposited in node delegator, the deposit pool, and the strategy, all the combined assets is the value total Ethereum pool.
Yeah, so Max, yeah, I think that's a good idea.
It's a deposit pool contract.
Oh, okay. Cool.
Okay, yeah, perfect right here. So yeah, just like
Okay.
Graham said,
Yeah.
it looks like this is summing. So we have three different spots in this protocol where funds can be. So let's walk through what's going on here. How are we summing all of those?
Okay. Looks like we're getting the asset distribution data from different function. That's just basically totaling up all of these different places where we can have capital
Yep.
and then returning them in one UA for the total assets deposited.
Okay, perfect. So we'll stop right there before we go into get asset distribution data. And let's go back to the Oracle we were just looking at. Okay, great. So we get that total asset amount. We're just summing, okay, what's the total ETH value deposited in the pool? And then on the last line of this function, now that we've gotten the total ETH value that's deposited in the pool, what are we doing here?
Dividing by the number of RSETH tokens that are in circulation.
Yeah, exactly. So what is that basically saying in context of what this function is called?
The value of RSETH.
Assets per share.
In Ether. Yeah.
Yeah, exactly. So it's saying like, okay, for all of the value, the ether value deposited in this pool, we're going to take all of that value and we're going to divide it up amongst each RS ETH that exists. And so that's basically the price of RS ETH is like how much ETH is in this pool to back an individual RS ETH. So
I don't see any like collateralization um, things with this. Like, I'm curious, like, what are the strategies? Or are they just not implemented here? They're implemented on like Eigenlayer.
yeah, Eigenlayer does all of the strategy logic, and we actually don't have to think
Oh, okay,
critically about what that is because that's kind of like a black
cool.
box from this protocol's perspective. But a part of that is in the if we go back to the get total assets function because I think there's something here that actually could be quite bad. Now,
As it sticks in Eigenlayer.
yeah, so let's go to get asset distribution data and I'm going to really quickly run to the restroom and then we can come back in 1 minute and we'll work through this. Um, and I think there's some interesting things to talk about here. But yeah, I'll be right back.
Okay.
So I think one of the most interesting function is get asset balances in node delegator because that's how they're calculating how much uh, the how much ETH is deposited into the strategy.
That makes sense. So where is get asset balance?
Yeah, it's a node delegator contract.
Oh,
This one, yeah, this function. So the value that we are getting in the get distribution data, of how much assets we have deposited into strategy.
Could you say that
Yeah,
again?
this one.
This function,
We
right?
need three values, right? Yeah, we need three
Yeah.
values. The amount deposited in the deposit pool, in the node delegator, and in the strategy. So
Yeah.
this function
Why-
get asset balance.
It looks like we're just getting two right here. And then balance of the deposit pool would be in black. Okay, cool.
Yeah, yeah.
Okay, let's stop right there on that line 79. What are people
Yeah.
thinking when they see this right here?
Why aren't they tracking individual positions?
I think that's good because what we're trying to do here is sum up everything that's in this pool in aggregate. So I think that should be fine because they're just dividing it
Okay.
amongst the total tokens. But what do folks think of when you see this balance of check?
They can send the pool the tokens, and they can just transfer it to this pool, and then the balance of will be inflated, no?
Exactly.
Yeah,
Exactly.
that's what
So
I was thinking of.
yeah, so let's think about this because uh, this is so anytime you see a balance of being used in the accounting, you should immediately think about some price manipulation attacks because I can, without having to deposit into this contract, I can just send those tokens to this contract and manipulate the price. I can manipulate the asset lying in deposit pool value, which will in turn change the amount of ether value that we're saying, which will change the price of this token, right?
Okay.
So,
So then the
I have a
recommendation is to have
question.
it be like access controlled as a function.
yeah, so
Maybe we should keep a variable track, right? Like a variable which would track the balance, increment it every time, and increment it every time the asset is deposited, and decrement it every time it's going out to the node delegators.
yeah,
So in that way,
that's
we can.
that's definitely one way to solve it is instead of just relying on the balance of this contract, you could say amount deposited, have like a storage variable for amount deposited, or it could be a mapping from asset to deposited balance.
Yeah.
And
I have a question.
yeah,
So regarding the price manipulation, if if a malicious attacker wants to inflate the price, they are sending the tokens to this contract directly. Like, wouldn't that be if they are sending the tokens and inflating the price and then trying to get profit off of it, they've already sent the tokens. So is there any way that they will withdraw those tokens, or like the tokens are already in the contract, right? So they have lost that much amount of tokens.
yes. So
So
we will see. Let's walk through it because I think we've actually got something here. Now, what Priyam is saying is, how can I possibly benefit from having to send tokens to this contract to raise the price,
exactly.
Yeah.
right? I've got to send the tokens. So how is that going to benefit me? Is anybody familiar with the first depositor inflation attack for
Yes.
like canonically it's used on ERC 4626 vaults.
Like to
So
Yeah,
burn
yeah.
the user shares.
yeah, so Priyam, maybe you could explain how does the inflation attack work?
Okay, so well, we have the vault, and consider that there are no users which have deposited in the vault.
Hmm.
So the first malicious attacker, they will mint a very small share, and then they will, wait for second user to deposit in the vault. So when the second user deposits in the vault, the first user, they will front run him and deposit a large amount directly without minting the shares. And this way, the token amount, like the share value, it will be inflated. And the given that the second user has deposited the amount, they will literally get minted zero shares or maybe very less amount. And the first user, they can withdraw their shares and they have inflated the price of the share. So that way they can, get a part of the second user's deposit.
Okay, cool. So Priyam, how do you think that could apply to this system?
Yeah, that can be applied. Let me just think. Get asset distribution. So the first user, they deposit, get some RS ETH minted, and then as the second user deposits, we can transfer the asset directly, and then yeah, we can withdraw it. Like we can literally apply the same concept here, right?
Yeah, exactly. So you just found a high in a Coterie contest.
Wow. Should have
Nice.
found it 3 days earlier.
Yeah. Oh, is the contest over now?
Yeah.
Yeah.
Yeah,
Yeah.
I bet.
Oh. Okay, so
That's awesome though.
so that was, quick, so we're gonna walk through it step by step and see how this works. But yeah, we just found a real high vulnerability here. So let's step through it. So we know that this asset lying in deposit pool, that's a part of the value of one of these tokens, right? And we know that we can manipulate that by transferring tokens directly here. So let's walk through a scenario. So let's say let's start off with uh, let's say somebody wants to deposit into this system. They're going to be the first person who's going to deposit. And let's say it is Bob. I'll go ahead and share my screen actually so we can just walk through this. And okay, good. I've got this. So let me go. So I've got the deposit pool and I've got the Oracle. Okay, so let's discuss. Let's say Bob. Bob, he's a normal user. Bob wants to deposit one, one RETH, one staked ETH from Lido, whatever, one liquid staked ETH token into the system, right? So he's gonna call. What function is he gonna call, guys, to deposit? Which contract?
In the deposit pool.
Okay, so you call deposit
Yes,
asset.
Deposit asset.
Yeah. All right. So he wants to be the first depositor. Now we can walk through. Let's show what happens normally, right? In a good situation, what is going to happen normally? Maybe somebody can just walk me through that.
I can, but if someone else wants, they can try it.
Yeah, let's have somebody else just mix it up. When I deposit one staked ETH, what happens?
Well, I can go if nobody wants. Normally, I would expect to deposit one staked ETH and get back one RS ETH as
Cool.
a share.
Yeah, so one staked ETH goes into the deposit pool, and then out of that, I get two Bob. He gets one RS ETH, which is like the receipt token, right? And then this isn't in the
Total
scope.
balance gets updated.
Oh, sorry, what was that?
Sorry, total balance gets updated. Obviously, it stays in the contract itself, right?
Yeah,
That's
yeah.
where
So
the
that's a good
comes with later.
second order effect is that now the balance. So Bob is the first depositor. So the balance in the entire system is one staked ETH, right? And that covers everything that's deployed in the node delegator. It covers everything that's deployed in eigenlayer. It is one staked ETH, right? Because at this point in time, nothing is in the node delegator, nothing is in eigenlayer. Does that make sense?
Yep.
Yep.
Okay, cool. So yeah, and that's an important thing to point out. So yeah, definitely good to call that out. So this is what normally happens, and now this is out of scope for what we're auditing, but we'll basically just assume that Bob is able to, at some point, come back, redeem his RS ETH, burn his RS ETH, and redeem the one staked ETH that he is rightfully owed, right? Because that's what the price is. So if we look at get RS ETH price. What this function will do in this case is, let's say supported assets. Let's say it's just staked ETH to make things really simple. So it will get the price of staked ETH. Let's say that staked ETH is just 1 ETH, just to make it simple. It won't be. It will be like, 1 point something ETH, but we're going to keep it at 1 ETH. We're going to get the total asset amount. What's the total asset amount? Can anybody shout it out?
1/8.
Exactly. Yeah, we've got 1 staked ETH, just to be particular, staked ETH, and then we're multiplying that by the price of staked ETH in Ethereum, right? So that price is Ether per staked Ether. That's the price. And so we're multiplying that by our staked Ether amount. And we cross these off. The units work out, we get Ether as a result. And that's why we increment the total ETH in the pool. By the way, you guys have seen me do this a number of times now. 100% recommend pulling out a whiteboard or even just a piece of paper and walking through the units. Same thing for the decimals. But yeah, so we get the total ETH in the pool. For us, in our example, that's one Ether. We divide by the RES ETH supply, which is 1 Ether. So the price that's reported for Bob here, if you were to call the price, it is 1E18, 1 Ether. That's what the price is, right? So 1 RS ETH is worth 1 ETH, basically. And that's what he can redeem it for. So now Priyam really quickly ran us through an attack scenario where Bob he wants to be the first depositor. So Bob wants to deposit 1 staked ETH. What happens is he gets front run. He was going to be the first depositor, but instead a malicious actor comes in, and let's say Alice front runs and deposits 1 way. So does everybody know okay, does anybody not know what 1 way is? Okay, I'm taking silence as everybody knows what 1 way is. Okay. Alice front runs, deposits 1 way. What happens when Alice deposits 1 way? Let's have a look. So she's going to deposit. She will be the first depositor. We have some checks. Well, the deposit amount is not 0. It's actually 1. But we'll see why they should actually have probably a minimum deposit amount or some solution for this. Certainly there's room to deposit. There are no deposits at this time. We're going to transfer from 1 way from Alice into this. So we're going to grab that 1 way. Then we're going to mint RS ETH. This is where the interesting stuff is. We're going to figure out how much RS ETH should we mint. And we're just going to go to basically the Oracle, and we're going to get the RS ETH price. Now, initially, the price is 1 Ether. So what she's going to do is she's going to give an amount, which is 1 way, times, we said the price of staked ETH is 1 Ether, divided by 1 Ether. So the result of this is a singular way. So this is going to be literally just 1 returned from this. And so that's how much is going to get minted to her. We're going to dot mint 1 way. So now the total supply of this token equals 1 way. Alice also has 1 way total supply, and this is for RS ETH. Okay, cool. So now this is still a transaction that's waiting to, it's been sent, it's waiting to get recorded in the block. Now, right before, still in Alice's front running transaction, she also decides to transfer directly to the pool. So let's say Alice sends 1 staked ETH straight to the pool. So now she doesn't get any more RS ETH for this because she didn't call the deposit function, but she did get this into the system. So the balance of deposit pool is now equal to 1 ETH plus 1. So 1 ETH and 1 way. That's what I mean by this. So this is like 1E18 plus 1. Does that not make sense to anybody? Okay, good. Silence is understanding. So Bob wants to deposit 1 staked ETH. Now he's going to actually do this. Now let's walk through. Now that we know that the balance of this pool is 1E18 plus 1, and the total supply is literally 1 way, let's walk through what happens to Bob's deposit. Okay, we're in the deposit asset function. We do the checks, passes the checks, transfer Bob's assets to the pool, and now we calculate, okay, we've got your ether. Your ether has gone into the pool. Now let's mint RS ETH based on that. There's another issue that I think I just realized, but we'll ignore that. Okay, so we're going to come into this function. This is where the interesting stuff is. We're going to get RS ETH price. So RS ETH supplies is no longer 0. It's a single way. Now when we come in, we're actually going to come into this for loop. We're going to call get total asset deposits. Can anybody tell me what does this return at this point in time?
Like 1
One and
plus 1.
one way.
Exactly. And I actually realized something that we'll touch on that also seems very wrong that has to do with that. But okay, so that returns 1 and 1 way, which is the balance of the system. So we get total asset amount, which is 1 and 1 way, times the price, which we said is 1 ether. So 1E18 plus 1 times the price of ether, which we said was 1E18. This is what's returned from this. This is the total ETH in the pool divided by the RETH supply. What's the RS ETH supply at this time?
One way.
Exactly. So divided by 1, well, that's pointless, right? So this is what's returned, right? You divide stuff by 1, it literally doesn't do anything. So we return 1E18 plus 1 times 1E18 from here. So let's go back. That was the divisor here. So let's write out this formula. So we've got amount times the asset price, so price divided by ETH in pool. And we'll fill in the values that we know. So Bob is trying to mint, or he's depositing 1 staked ETH, 1E18, times the price of that, 1E18, divided by the ETH in the pool, which we put here. So I'll copy this. And what does this equal in solidity?
0.
0. So Bob puts in 1 staked ether and he gets 0.
0 shares.
0 shares. And so the withdrawal manager isn't in scope, but we can only imagine that now the attacker would be able to withdraw the ether that Bob deposited. So the attacker put in 1 staked ETH that he transferred directly, and he also put in a single way. So he put in basically 1 staked ETH, and he can withdraw 2 staked ETH. So that is the exploit here. Does anybody have any questions on any of those steps we went through?
How does the attacker withdraw 2 staked ETH instead of just 1?
Yeah, so the attacker
Or is
has...
there like a fallback function or something that's going to be exploited?
No, let's have a look at the balances of RS ETH. So here's Bob, and here's Alice. Alice was the front runner. She got 1 way of RS ETH. And how many RS ETH did Bob get?
1.
0.
Well, none.
0.
Yeah, he got 0. And
Oh,
so when we talk about like, okay, how much funds are in the system now? In the system, there is two essentially two, technically there's another, there's that that's what's in the system is two ether in a single way, right? That is everything that's in the system.
Yeah.
Now, if what we're doing when we're calculating the price of a single RS ETH is we're just dividing the total ETH in the pool by the RS ETH supply, then what's the price?
Oh, okay. So it'd be 2 E18 plus 1 divided by 2, right?
Yeah, divided by just literally
Or by
one.
1. Sorry.
Yeah. And
Yeah.
so Alice is the only person in the world who owns RS ETH. And if RS ETH is backed by whatever's in the pool amount, then Alice owns everything in the pool amount, right?
Right.
And so she can redeem that RS ETH and get everything in the pool because she's the only one who owns the pool.
Oh, okay. So we're just assuming that the withdrawal functions are just like mapped to whatever individual user's deposit.
Yeah, exactly. And that's what this get RS ETH price is saying, is that for everything in the pool, that's divided up against everybody who has a share in the pool. But if Alice is the only person who has a share in the pool, then she just owns everything in
Right.
the pool.
Okay. Makes sense.
And so there we have it. That's how we are basically stealing from Bob. So good job, guys, for working through that, and we've literally found what I expect to be one of the high issues in this contest. If it's not reported, then we'll have found a unique that we didn't even get to report, but I expect that should have been found.
Wait until they deploy. Take your crucifix.
Yeah, keep your eyes out, guys.
Black hat.
What was the other issue you saw?
Yeah, so the other issue I just noticed, maybe I'm forgetting something, but what they're doing is they're transferring from the message.sender to this contract. So you get the balance before you actually go and ask the question, how much money is in the system? So actually, when we answered that question, we said, when I asked you how much ether is in the pool, and you guys told me 1E18 plus one way, uh, that is what would be the right answer and what we would expect. But actually, since Bob's transfer from comes before, it would actually be 2E18 plus 1. So I think that's actually a much larger issue, right? We're doing the transfer from, and remember that will increment the balance of this contract. Then we go into mint RS ETH. We get the RS ETH amount to mint, which of course relies on this function up here, which gets the balance of this address. Well, Bob literally just transferred in, so he just incremented this by his own tokens. So instead of returning 1E18 plus 1, this would actually return 2E18 plus 1, which does not make sense for this calculation. So is that
So even if you add a check for a minimum deposit, the attack will still take place, right?
yeah,
Because of that
you'd be
additional
attacking
ETH.
yourself, yeah. Yeah, so I think that's a pretty critical issue as well. It's like I think yeah they've got a
Yeah, it would mess up the share value, right? The how much RSE to be minted because of considering the balance first.
yeah, because it's literally counting the balance that you're transferring in as already being a part of the pool, whereas that shouldn't be accounted for.
So you basically front run yourself.
Exactly, every time.
So what would be the recommended fix for this? Like a minimum deposit check?
Yeah, so
That's
for the first issue that we talked about,
Yeah.
there are a number of ways to basically handle this. You could require that the initial like few number of shares are minted to some like dead address, so they're like locked away so that this can't happen. So notice this is only a risk for the first deposit, because in the first deposit, that's the only time that I can set the exchange rate such that, I've made the total supply one way, because we need the total supply to be one way, because when we actually go and we use the total supply, to figure out how many tokens you should be minted. Let me find it. I'll find it. It is, okay, so it's a little confusing, but it's in the divisor of what is returned for the price. So we wanted to make this a single way so that when we divided this thing, the return value here would still be big. But if the RS ETH supply is bigger, it's impossible to pull off this tech. So first solution, require the protocol to mint the initial shares so nobody can be the first depositor. Second solution, have a minimum deposit. And for this system, I think those are the two best ways to approach this.
For the second issue, like every time if a user deposits, wouldn't they get less shares minted back because we are considering the new value?
Yeah, that's exactly what's happening. So what should happen here is they should do this. They should first cash the amount that should be minted. They shouldn't actually mint this amount in here. They should just calculate what needs to be minted, and then here, now mint. So make the actual state changes here after you've transferred in, but calculate the amount to mint before you transfer in. And also, another solution to all of this is to just stop using balance of. Don't use balance of. Have a mapping that's like token to balances, and only increment that like at the end of this function. That would solve all of these issues. So yeah. All right.
But we can still consider this as two different issues, right?
Yeah, these are two
Given
different.
that they are, yeah, got it.
Yeah, I would say these are sufficiently like distinct from each other. Because like even if you added like a minimum output or a minimum deposit, you're not going to fix this, right? So definitely two different issues.
But they are being caused from the same root cause.
No, I would say they're different root causes. Because
Okay.
one of them is like a inflation attack, the other one is just a straight up logical error.
Yeah. The root cause is that we are considering the actual balance of the contract, right?
I would say the root cause for, because there is a way to consider the balance of the contract and still have that minting calculation work out. So yes, there is a solution that solves both, but the most simple solution for the first one doesn't solve the second one. So there's a little bit of differentiation there.
Okay.
All right, cool. Anything else you guys wanted to touch on?
No, just like that transfer, like, and you like set it as a low issue that you don't know if it's gonna return like a true, like a boolean, or like you know that there are three assets, but maybe you add a support for an asset that doesn't return true on the transfer function.
Oh, you're talking about like what a asset returns?
Because it basically, when you transfer from like the assets in the deposit function, you do a normal transfer, and you expect that that function returns a boolean, which is true. But what if it doesn't
Yeah,
return true?
that's another reason that you should just use safe
Safe
transfer
transfer.
is that they might not return any return data at all. And so I suspect that's maybe even a third high finding is, well, I guess uh, they will probably say it's like a low because they know what tokens they're supporting, and they could say for the tokens we're supporting, we know the implementation, we know all of them will return a Boolean value. But if they're supporting any arbitrary token, you should just use safe transfer. You should just use safe transfer always, because the token might not return any return data, and then how are you going to compare that as a Boolean? It will just revert trying to treat zero return data as a Boolean. So yeah, that's a good point.
Okay, cool, thanks.
All right, so I hope seeing this live contest in action was useful for you, and I hope that maybe you've seen some of the approaches that I've taken and some of the questions that I've asked myself, and I hope that you'll be able to take that and apply it to your own methodology and see how you can improve as a security researcher just based off of doing this contest with me and sort of walking it through as I completely open up the code base and go from absolutely zero to understanding it to finding stuff with it. Hopefully you can take that and apply it to your own methodology. And of course, if you're really interested in this security research stuff and you're looking to become a really skilled security researcher, maybe you want to become a senior auditor in a matter of months rather than a couple of years, and avoid all of the trials and errors that I personally had to go through when becoming a security researcher, then in the description below I went ahead and I put just the 6 things that, looking back, I see as being core pieces that are needed to become a senior smart contract auditor. And if that's something that you're interested in, you can go ahead and grab that in the description below. If it's not, that's totally fine. Don't go and grab it. You wouldn't want to do something that you don't want to do. But beyond that, if you're interested in just connecting with a group of people across the world who are also interested in this security research stuff, and if you'd like to learn more, connect with others, then you can go ahead and join our free community at lab.guardianaudits.com, and I hope to see you in there. All right, look forward to seeing you next time.